What's up, everyone? This is LeetCode 208, implement trie or prefix tree. We've done this problem in Python. Now we're going to do it in C++. So a trie or prefix tree is a data structure used to efficiently store and retrieve keys in a data set of strings. There are various applications of this data structure, such as autocomplete and spell checker. Yeah. Like I said in my Python video, I think this problem is a knowledge check, personally. Like, I think if you don't know what a trie is, it's obviously going to be hard to implement a data structure you have no idea about. So I would click this blue link and read about trie. Or the prefix tree and how it works. Okay, I'll do kind of a brief explanation illustration to explain it, but you should do it on your own also, or look it up on your own also in case you don't understand my explanation. So we're gonna have to implement this class, right? We're gonna have to initialize the object, insert the string word into the trie, implement this Boolean search function, and this Boolean starts with function, which basically is just checking if a prefix of a given word, if there is a prefix in the trie already, from a word we already inserted previously. Okay, now I'm going to show you how trie works. But again, recommend looking it up on your own in case you don't understand what I'm showing you, and my explanation is not that good. I think it will be okay, but so this is what a trie is, right? We're gonna have again, this is for storing and retrieving strings. So we're gonna have like a starting node, basically, like think of it just kind of like a starting place, and we're gonna have letters, okay, and then those will branch out to other letters, and these will build out words over time, right? And basically, how do we know if a given word is in our trie? Well, that's because we're gonna have a Boolean variable called end of word, right? And when we reach the end of a word, we're gonna set that to true. Technically, these all have the same Boolean variable. It's just that I didn't explicitly show you that. These technically all have false, right? Because ORI technically is not a word, so it's set to false. And by default, they're all false until we set it to true. So, for example, or is a word, so we set this to true, right, for this final node. But we can keep going and build out other words, right? At this end, we set this to true also, right? Why? Because origin is a word. Likewise, you go here, right? Wait is a word, so at this T, this gets set to true because from here to here, this is a word, right? Here, same thing, we set this to true. Why? Because from here to here, it's a word, waitress, right? That's kind of how a trie works, and we have to implement this data structure, okay? So the way we're going to do this is we're going to have a class called trie, and we're actually going to implement another class called trie node, okay? And the reason we're going to implement another class called trie node is because it'll help us set up the actual individual nodes. And it'll make this problem a little bit more organized and simple to understand. So when we have a node, right, and we create it, we're going to have a hash map, okay? We're going to say unordered map, character, trie node, children. Additionally, when we create a node, we're going to say end of word as a Boolean. That's going to be set to false. Okay, now let me explain the hash map. Basically, when we create a node for a specific like letter, we're going to have a hash map, right? And the key in the hash map is going to be the children, okay? Now, why is this? Because it'll help us with lookups, right? It'll make it faster. The value is really like a placeholder, right? So don't worry about this too much. What's most important is the key, because that'll help us with fast lookups for children. When we're at a given node, if we want to see its children, we can just use the hash map, the key in the hash map, and it'll help us with fast lookups. Okay. So that's basically setting up our trie node. Okay. Now we actually set the trie class up. Okay. So up here, right, we're going to set trie node root. Now this root basically is this part right here, okay? Now when we declare this, right, we have to say root, and we actually have to make sure it's an actual trie node, right? Right? That we defined up here. Okay. Now we have to do the insertion. Okay? Now the way we're going to start this is we're going to create a node called current and set that to root. Okay? So current initially is up here. Okay. So we're gonna say for char in word. Okay. So we're given an input, which is a word, and we have to check. Or no, we don't have to check anything. We have to insert this word that we're given into our try. Okay. So the way we're gonna do this is we're basically gonna check if the character is not a child of the current try node created. Okay. So we're gonna say if for dot end. Then we have to do cur children c to try node. Right? Ooh, and then after this we can move on to the next node. Now really two cases where we move on to the next node. Either we created this node and moved to it, or this node already existed, so no need to create. Just move onto it. Okay. And I'll explain what I mean here in a little second. CH. Okay. So for example, let's say we wanna let's say we wanna insert the word Oreo, right? Like the cookies, right? When we're starting here, we're checking the child node. Okay. We're checking for O. Is O a child node here? Yes. Okay, so we're just gonna move here. Okay, we're not actually doing an insertion because O already exists. Is R a child node of O? Yes, so just move to it. Okay, is E a child node of R? No, so we actually have to create it, right? And then we move on to this E. Okay, is O a child node? Obviously not. So we have to create it and move on to it. Okay, so now Oreo is inserted into our try. But remember this part here? We actually have to set this to true, right? So at this O, we have to set this Boolean variable to true to indicate that we have a word. Well, that's the wrong color. That we have a word right here, right? We go Oreo. So this is a word. So this O here has to get set to true to let us know basically at this O, we have an actual valid word. Okay. So outside of this for loop, when we insert the entire word, we have to do per end of word true. Okay. So yeah, that's the insertion. I don't think it's too complicated. I hope I explained that okay, especially with my illustrations. Now, these two functions here, search and starts with, they're very similar, but there's a slight difference, right? One, in search, we're looking if a word exists, okay? Whereas in starts with, we're looking for if a prefix exists. So in essence, we need to make sure we don't check if a prefix exists in search because we would get the wrong results, okay? I'll explain what I mean at the end of this function, okay? So much like the insertion, we want to start at the top, right? At the top of the try. So we're going to say, again, we're going to say try node, right? For the root, okay? And we're going to say for ch word. We have to search if this word exists in our try, okay? So very similar to the insertion, we need to check, does this character exist or does it not exist, right? So we're going to say if per children ch, I should say children dot find ch per dot end, right? If child does not exist for a given node, then we return false. Oops. then we return false. Yeah. So for example, if we're looking for the word, I don't know, baseball or something, well, when we're starting here, there's no B, right? There's no child nodes that has B, so we just return false. Okay. Else, right? This else is basically means the child does exist. So we want to like we did up here, we want to move forward, okay? Because we want to keep searching to make sure the actual character exists, but we want to check the rest of the characters, make sure that they exist as well before we return anything. Okay? And we want to keep doing that, okay, until we exit our for loop. Okay? And then right here we want to return per end of. Now, if we get here, right? If we get here, what does that tell you? Well, it tells you we exited our for loop, right? And we never returned false. So do we want to return true here? Think about it. No, we don't, right? We don't. And I'll explain why, okay? I'll give you a very easy example to understand why we're returning cur end of word here instead of just returning true, right? Let's say our try has the word toaster in it, right? That word, but we're searching for the word toast, right? So we check here, okay, does the T exist? Yes. Does the O exist? Yes. Does the A exist? Yes. Does the S exist? Yes. Does the T exist? Yes. So we searched our entire word, so we would exit this for loop. But we would not want to return true because toast does not exist as a word in our try, only toaster does. Toast exists as a substring, as a prefix, but not as an actual word, right? So if we return true here, right, that would be incorrect. So, because when we go to this T here and we do end of word, this T here is going to point to a node that says false, or to a variable that says false, right? The end of word variable for this T is false because toast is not a word, only try is. Or sorry, not try, only toaster is a word in our try, okay? Now here is where we actually do want to do that, right? This is a little bit different, okay? I need to make sure I change this variable, by the way, because the input is not word, it's prefix. So, prefix. Now here, for example, this is different. Here we actually do want to return true. It's the exact same code, it's just the return statement is a little bit different, right? Because here, for example, if our prefix that we're given is toast, but in our try, we have toaster, the prefix toast does exist, right? T-O-A-S-T. The prefix toast does exist for a word already in our try. The word happens to be toaster. So we do want to return true in this case. See what silly mistake I did. Line 6. Oh, my class needs to have a semicolon. Not sure if I have any other silly mistakes here. Nope. Looks like we're good. Okay. So yeah, passed all my test cases. Not a lot of test cases actually for this problem, but yeah, here's my code, right? I'll scroll down, make sure you see the rest. So yeah. Really, I think two things, right? To make sure you understand this problem. One, you need to understand what a try is and how it works, right? Because like obviously implementing this is very hard if you don't even know what the data structure is. That's why I said at the beginning of this problem, like this problem is a knowledge check more than anything. If you don't know the data structure, how can you implement it? Like it's like impossible. You actually have to know how the data structure works. It does feel kind of unfair, right? Given a problem like this, like I never heard of a try. How am I supposed to solve it? I know, I understand that. So that's just how, that's just how these types of problems are. Sometimes you have to just, like I said in other videos in the past, you're gonna learn new things as you LeetCode that you never knew, and you just gather the knowledge, right? Put it in your back pocket, and someday you'll use the exact same knowledge on a different problem. And this is one of them, right? If you've never heard of a try, well, now is your time to learn, right? And I was like the same way when I first came across this problem too, so don't feel bad. But make sure you understand what a try is, and then the implementation will be easier. And secondly, what I wanted to say is you just make sure you understand how our hash map is working, and it'll make sense, okay? When we're at a given node, right? When we're at a given node, like, let me delete some of this stuff. It's really crowded, right? When we're at a given node, right? Like I, or maybe not I. Let's say, okay, let me create the example I had before. Let's say Oreo is a word, right? And obviously this is true, right? We basically reach the end, okay? So this is a word, Oreo. Now, when we're at this R, the keys, we have two keys. We have E and I, right? So the reason these are keys in our, like basically every node has a hash map, which has a hash map where the key is its children, right? And the reason it's set up like that, again, is for fast lookup, right? And the value in the hash map is just trie node, right? And again, this really is not important. The value is not important. It's kind of like a placeholder. What's important is the key, which is the children, okay? So make sure you understand how we're actually using the hash map also, and it'll make this problem make more sense. I was actually stuck for a little bit before, I wasn't like, I've seen various videos, use a hash map, do this, do that, and they weren't explaining why do we set up the hash map the way we do, right? And it's because of how useful it is to have the children as keys in the hash map for fast lookup. Okay. Yeah, and you can probably understand how we could use a trie to autocomplete stuff, right? You type in 2 letters and you have a bunch of words that could be possible that start with those 2 letters. Like you put the letter B in a Google search, and right, maybe you're looking for baseball, maybe you're looking for burrito, but right, because Google search doesn't know what you're looking for. All it knows is you're looking for something that starts with the letter B. Okay, what are words that start with the letter B, but what are words that start with the letter B and are different? Baseball, burrito, basketball, whatever, right? So anyways, I hope this helped. This video is a little bit long, sorry about that, but again, I really like going into depth on my videos, because I feel like a lot of LeetCode videos really don't, personally, and I think they leave a lot of open-ended questions and they can be quite confusing. And I also make these videos for myself in the future, so I hope you found value in this video, and yeah, I'll see you in the next one. Peace out.